Hello everybody, welcome to Chapter 6.1, Part 2, Rationalizing the Denominator. Rationalizing the denominator. In most cases, you don't want to leave the radical in the denominator. So rationalizing the denominator is a way to rewrite the expression without radicals in the denominator. Radical rules: no radicals in the denominator, no fractions under the radical sign, and apply the properties of radicals and exponents. How do you know when a radical problem is done? Well, as just explained, there are no radicals can be simplified. So, for example, the square root of 8 is not simplified because this can be further simplified to square root of 4 times 2, and that means square root of 4 can be taken outside of the radical. There are no fractions in the radical. So, for example, here we have underneath the radical sign 1/4, and this is not good. So we have to use our quotient radical rule so that we end up with 1/2. There are no radicals in the denominator. For example, we have a square root of 5 in the denominator, and that is not permitted either. Example number 1. We want to simplify the square root of 108 over the square root of 3. So let us go over to the whiteboard and work this one out. And example number 1, we have 108 over the square root of 3. So the square root of 108 over the square root of 3. Now this is no good because we have a radical sign on the bottom. But if we note, it turns out if we do one of the things from our division rule, we can write 108 over 3. And it turns out that 3 goes into 108 36 times. And it turns out that indeed 36 is a perfect square 6. So that solves our problem. Reviewing what we did on the whiteboard in example number 1, we find that there was a radical in the denominator. Oh no! So what we did was we set it up as a fraction inside the radical in order to simplify it, and we found that 108 can be divided by 3. So that gives us the square root of 36, and the square root of 36 is a perfect square, so we get 6. Whew! It is simplified. In example number 2, we're asked to simplify 8 square root of 2 over 2 square root of 8. And if you notice, there's a radical in the denominator. So let us go over to the whiteboard and simplify this one. Number 2 is a little bit trickier because here we have 8 over 2, and the 8 is connected with the square root of 2, and 2 is connected with the square root of 8. And it turns out, well, let's simplify this. So we know 2 goes into 8 4 times. But we're still left with the square root of 2 and the square root of 8 on the bottom. Well, what we can do is the opposite, do what we did here, and we can do 4, and we have 2 over 8 inside there, and we can simplify this inside here. So we can get 4, 1 over 4, and as you see, 4 is a perfect square. So it turns out what we get, and I'll just put a 1 there so you know exactly what I'm doing when it comes to things that are fractions. So I have the 4, and this I can make 1 square root of 4, like that, because the square root of 1 is 1. And then we make 4 over 2, and then it turns out 4 over 2 is 2. So these are some little tricks that you can use to keep from having radical signs in the denominator. Reviewing what we just did on the whiteboard, we found, that there was another radical in the denominator. So doing some simplification, we had 1 square root of 1 over square root of 4, and we were able to reduce that to 4 over 2, which gives us 2 as our final answer. Wow, we got rid of that radical in the denominator. In example number 3, there's a fraction in the radical. So now let us go over to the whiteboard and work this one out and see how we can resolve this issue. Now sometimes you can't use any of the tricks that I just showed you. So for example, if we look at the next example, example number 3, and we have square root of 5 over 7. And then what I do is I'll go square root of 5, square root of 7. That doesn't help us. So you may ask, well, what do? Well, we do something called rationalizing the rationalizing, rationalizing the denominator. Rationalizing the denominator. And that's what we're going to do now because we're stuck. We can't have that. That's a no-no. Having this radical sign on the bottom is a no-no. So what we do is we look at this one on the bottom here, and we say what we're going to do is we're going to multiply the top and the bottom by the 7. So we have, square root of 7. So we have 5 square root of 7. And so what I'm going to do is I'm going to look at that square root of 7 because essentially when we have the same thing over the same thing, it's really equal to 1. So this is kind of a tricky trick. So what we do is what we usually do, we'll put together 5 times 7, and then bottom here is 7 times 7, and here, if you notice, we have, 5 times 7 is 35, and on the bottom here, we have 7 squared, so that means we can take out that 7 because it's a square of a square root, and we end up with the square root of 35 over 7, which means that we're in good shape and everything is fine. This is called rationalizing the denominator. Reviewing what I just did on the whiteboard, since the fraction doesn't reduce, split the radical up. So we did. But how do we get rid of this square root of 7 on the bottom? Well, we multiply by the fancy one to make the denominator a perfect square. And that was the role of doing this. And we ended up with the square root of 35 over the square root of 49. Since 7 radical 7 is equal to 49 under the radical sign, and 49 is a perfect square. And it turns out 49 is 7. And 35, well, we can't reduce that any further, so this becomes our final answer, the square root of 35 over 7. In example numbers 4 to 6, we want to write each of these expressions in simplified form. So in number 4, we have 5 square root of 3. So let us go over to the whiteboard and see how to do this one. Example number 4, we have 5 square root of 3 on the bottom. Well, we know that the square root of 3 on the bottom is no good. And even if we put the 5 and the 3 together in some way, meaning make that 25, 3 doesn't go into 25. So there's no other trick that we could use. So the only thing we can do is what we call rationalizing the denominator. So I look at that square root of 3 and I multiply the top and the bottom by square root of 3, square root of 3. And then I see that I get 5 square root of 3 on the top, and on the bottom is 3 times 3, which will give us 5 square root of 3 over square root of 3 squared, perfect square. So now we have 5 square root of 3 over 3. And now no problem, no radical sign on the bottom, no fractions, and everything is simplified. Reviewing what we did on the whiteboard, we rationalized the denominator in order to get rid of the square root of 3 on the bottom, so we multiplied it by the square root of 3 over the square root of 3, and we got 5 square root of 3 over 3. We cannot simplify this any further, so we are finished. In example number 5, we have square root of 7 over square root of 20. And as you see, we have a square root in the denominator, so we're going to have to fix that one up too. So let us go over to the whiteboard and see how we do this. We have square root of 7 over square root of 20. Well, make your life easy. We can see that there's nothing, even if we put it under one radical sign, 7 doesn't go into 20. That wouldn't help us. So we're stuck rationalizing the denominator. So I'm just going to multiply the top and the bottom by the square root of 20. So what do I get? That means that I have here square root of 7, 7, that's 7, square root of 20. And then on the bottom, I have 20 times 20, which of course gives me the perfect square and pulls out the 20. And my top part, I still have 7, but I can break my 20 into 4 times 5, where that 4 is the perfect square. On the bottom, I have the 20, so I can just put that. And since the 4 is the perfect square, I can just pull out the 2 from that perfect square, and I get 7 times 5 there, and that means that's 35 over 20. But I can simplify this even further, because it turns out that 2 goes into 20, and this can become 10, and this goes to 1. So my final answer will be square root of 35 over 10. And that will be my final answer for number 5. Reviewing what we just did on the whiteboard in example number 5, we rationalized the denominator 20 over 20, and so no longer do we have a square root of 20 on the bottom. Then we broke it down into its perfect squares, and we ended up with 2 square root of 35, but then we saw that 2 goes into 20 to give us square root of 35 over 10. In example number 6, we have 1 over the square root of 2, and again we have a square root in the denominator, so let us go over to the whiteboard and work this one out. We have 1 over the square root of 2. Now, you can't just flip it over and go flippy-floppy and think you can turn a 1 over something into the 1 over square root of 2 into the square root of 2. You cannot do that. Fractions will be fractions. Do not make fractions into non-fractions. So what you must do here is you must rationalize the denominator again. So we have, so I'm just going to multiply it. Square root, so 2, 2. And that's equal to square root of 2 on the top. And here we have 2 times 2. So square root of 2 on the top. And then 2 squared. And that's the same thing as saying the square root of 2 over 2. And there's nothing further we can do with that. Don't try to make stuff that's going on that's not there. Be very, very careful. Don't do the silly things. Okay, so here we have it, a few examples, and we'll do a few more examples. Do it using some of these techniques. Reviewing what we did on the whiteboard, in example number 6, we rationalized the denominator. Since it's square root of 2 on the bottom, we did square root of 2 over square root of 2 to rationalize it. And we ended up getting square root of 2 over 2. In example number 7, we have square root of 6 over square root of 7. So let us go over to the whiteboard and work this one out. Well, this looks like one where I have to rationalize the denominator. So I'm going to go 7 square root of 7, and that's going to give me 6 times 7 over, and remember this is just going to come out as 7, and that's going to give me the square root of 42 over 7. And that's as much as I can do with that one. Reviewing what we just did on the whiteboard for example number 7, we rationalized the denominator in order to get rid of the radical on the bottom here, and we used square root of 7 over 7 to do that, and we got the square root of 42 over the square root of 49, and square root of 49 is a perfect square, so we got square root of 42 over 7, and that was our final answer. In example number 8, we're asked to simplify square root of 5 over square root of 10, so let us go over the whiteboard and work this one out. Square root of 5 over square root of 10. Well, I can maybe make it a little bit simpler by doing this. 5 over 10. And I can see that that would be the same thing as 1 over 2, which would be the same thing as the square root of 1 square root of 2, which would be equal 1 over square root of 2. Now, I believe we saw something like this earlier, but I'll work through it again because it's not in its proper form. So what I'm going to do, I have no choice. I've tried everything I could, my other trick, but it still gave me a square root in the denominator. So now I have no choice but to rationalize the denominator. So I have 1 over square root of 2 times square root of 2 over square root of 2. And that's equal to the square root of 2. And as we discussed earlier, since we have 2 of the same, that will give me 2 square root of 2 over 2. Reviewing what we did on the whiteboard in example number 8, We have to rationalize the denominator, so here I rationalize it with the square root of 10 over 10, and that gave us under the radical sign 50 over 10, and 50 can be simplified to 5 square root of 2 over 10, and then of course this can be simplified to square root of 2 over 2. In number 9, we're asked to simplify 4 square root of 5 over square root of 10. So let us go over the whiteboard and work this one out. In number 9, we can use the trick that we just did. So we have 4 square root of 5 over square root of 10. As I said, you can just rationalize the denominator and do that one straight out the way it is done in the PowerPoint, or you can do it this way, the way I'm going to do it now, which is a little bit different. 5 over 10, and I'll put this here as a place marker so you don't confuse fractions with whole numbers. And that's going to be equal to 4 of 1 over 2. So there we have 4, and since the square root of 1 is 1, over the square root of 2. We still have to finish that up because we have an issue with that square root on the bottom. So now what we do is we have now 4 square root of 2, and then we found earlier that that would be equal to 2. And of course we can now make this 2, so that will be 2 square root of 2. So in that case, I'm just combining our tricks, or you can just go straight out and rationalize the denominator using the square root of 10. But again, either road you take, you should end up at the same house, meaning the same answer. In reviewing what we did on the whiteboard, for example, number 9, we rationalized the denominator with square root of 10 over 10. We got 4 square root of 50 over 10. We simplified to get 20 square root of 2 over 10. And then we simplified it further to get 2 square root of 2. In example number 10, we're asked to simplify square root of 3 over 2. And here we have a fraction inside the radical sign, so we have to simplify it to make sure that it is not like that. So let us go over to the whiteboard and see how we would simplify this one. We have 3 over 2. Just right off the bat, that's no good, because 3 over 2 is a fraction under a radical sign. So I'll just rewrite that, at least to take that out of the, because I can't reduce that any further. So now I see, here I have the square root of 2 on the bottom. I'm going to rationalize the denominator. 2, this is not 2. So I'm going to rationalize the denominator, and this will give me over 2, since these are both the same. So that will give me square root of 6. 3 times 2 is 6, and that is all right. Reviewing what we just did on the whiteboard, for example, number 10. We took the fraction underneath the radical sign and we broke that up into 2 radicals, one on top, one on bottom. And then we rationalized the denominator with square root of 2 over 2, since the denominator was square root of 2. And then we simplified to get the square root of 6 over 2. And this was our final answer. In example number 11, we're asked to simplify the square root of 3 over 4. And again, we have a situation where we have a fraction under a radical sign. So let us go over to the whiteboard and work this one out. 3 square root of 4, this doesn't help us any. So I can rewrite that now as 3 square root of 4. But this is very, very nice because we end up having a perfect square on the bottom here, and we end up with 3 over 2 since 4 is a perfect square, so there's no need to rationalize any denominator. Reviewing example number 11, we found that we can just break the radical into square root of 3 over square root of 4, but it turns out square root of 4 is a perfect square, so it was simplified to the square root of 3 over 2. In example number 12, we're asked to simplify 30 times 2 over 5, all under the radical sign. So let us go over to the whiteboard and do this one. 30 times 2, and that's all under over 5. Well, it turns out we can simplify this. So that gives us, so there we get rid of that radical or potential radical on the bottom, because it turns out that 5 goes into 30, and we end up with 6 times 2, and that's equal to the square root of 12. And now we want to simplify, because remember, our last rule is we have to have our radical simplified, so we know that hidden in 12 is 4 times 3, and 4 is a perfect square, so we have 2 square root of 3 as our final answer. Reviewing 12, we simplified it, so we get square root of 6 times 2, and that is equal to the square root of 12, and then we further simplified it to get square root of 4 times 3. We took out the 4 to get 2 square root of 3, and that was our final answer. In example number 13, we're asked to simplify 5 over 9, so let us go over to the whiteboard and simplify this one. Square root of 5, square root of 9. These can't be simplified with each other, but we end up having a square root of 9 on the bottom, and that's a perfect square. So we have 5 over 3, and there's nothing more we can do with that. Reviewing example number 13, we broke the radical into a radical on top and a radical on bottom, and we saw that the square root of 9 is a perfect square, so we simplified it to square root of 5 over 3. In example number 14, we're asked to simplify the square root of 3 over 8, and again we have a fraction inside a radical, so let's go over to the whiteboard and do this one. Let's see what we can do with 14. We have 3 over 8. Nothing can be simplified inside there. Square root of 3, square root of 8. It's not a perfect square on the bottom. But another kind of tricky thing we can do is we can actually simplify the square root of 8. We can just do square root of 8, square root of 8. That's fine too. But I'm just going to show you another little trick. So I can pull out and do this. So I have, because 8 is 2 times 4, square root of 3, 2, square root of 2. Now what I'm going to do here to rationalize the denominator is I'm going to take the square root part. So I'm going to do square root of 2, square root of 2 here. And I end up with 3 times 2 over 2, square root of 2 times 2. So that's going to give me the square root of 6. And then the 2, square root of 4. Well, we know the square root of 4 is 2. And then it's going to be 2 times, so there we get square root of 6 over 4. So this is one clever way to do it. Of course, you can rationalize the denominator just going straight out to the 8, but eventually it'll simplify to this form. Reviewing what we just did for 14, we separated into two radicals on the top and the bottom. In the bottom one, we saw that we have a hidden perfect square, so we put the square root of 4 times 2. We saw square root of 4 is a perfect square, and then we rationalized the denominator in order to get square root of 6 over 2 times 2, which is square root of 6 over 4, and that was our final answer. In example number 15, we have the square root of 1 over 6, so let us work this one out on the whiteboard. All of that underneath, so then I can break it. And the square root of 1 is 1, square root of 6, but it looks like I'm stuck rationalizing the denominator. Which is equal to the square root of 6 over 6. Reviewing what we just did in 15, we put it in terms of square root of 1 over square root of 6, multiplied it by square root of 6 over square root of 6 in order to rationalize the denominator, and we ended up with square root of 6 over 6 as our final answer. In number 16, we're asked to do the square root of 25 over 3, so let us go over to the whiteboard and do this one. Well, we see 3 does nothing we can do. 25, square root of 3. Well, of course, I see that's a perfect square, so I can put that 5 over there and square root of 3. But I'm still stuck rationalizing that denominator. There's no other trick I could use, so I'm stuck doing this in order to get rid of all that. And then I have 5 square root of 3, and of course 3 appears twice, so I have 5 square root of 3 over 3. And that's my final answer. Reviewing what we did in example number 16, we found that after we separated the fraction, we got square root of 25 over square root of 3. We saw that square root of 25 is a perfect square, but we were still stuck with square root of 3 in the denominator. So we rationalized the denominator using square root of 3 over square root of 3. And we got 5 square root of 3 over 3. And that was our final answer. In example number 17, we have square root of 5 times square root of 70 over square root of 7. So we see this one's a little bit more complicated because we also have the multiplication. So let us go over to the whiteboard and work this one out. Now let's look at example number 17. Now, of course, you can do it using rationalizing the denominator. So we have 5 times square root of 70, square root of 5, all over square root of 7. Now, of course, because we have a square root of 7 in the denominator, you can rationalize the denominator, and of course, eventually, you'll get the right answer. But there's a lot easier way to do it without even bother rationalizing in the denominator, because if you see, if we take all these square roots and we put it together under one root, under one square root, we have 5 times 70 over 7. And we can see right away that 7 goes into 70 10 times. So that means now we have the square root of 5 times 10. And this means, so now we already, just by that little understanding our multiplication and our division rules, we can now simplify this so much so that we can now have 5 times 5 times 2. And we see now we have the perfect square here. So that means we can pull out the 5 and have square root of 2. So in this case, we can find actually a simpler method than rationalizing the denominator. Now, of course, we can do this rationalizing the denominator, and indeed we will get the same answer. So it's up to you how you would want to do a problem like this. In reviewing what we did on the whiteboard, we discussed there's probably 2 different ways of going about number 17. So one way was to split everything up into perfect squares and find that we get 5 square root of 14 over square root of 7, rationalize the denominator in order to get 5 square root of 2 after simplification. Or we could have done it a different way and started canceling out right in the beginning, noticing that we had square root of 7 over square root of 7, and then ended up with square root of 50, and then simplified the radical in order to get the same answer. In example number 18, we have square root of 7 times square root of 42 over square root of 3. So let us go over to the whiteboard and work this one out. Square root of 7, square root of 42, all over square root of 3. Now again, we can rationalize the denominator so we can get rid of that square root of 3. But again, like number 17, we can also find an easier way to do it just by putting everything together under the same radical sign. And we see that we can break down 42, so we can have 7 times 7 times 6 over 3, and that is equal to 7 times 7 times 3 times 2 over 3, and there we go. The 3's cancel out, so now we have 7 times 7 times 2, and there we have our perfect square. So there we can just have 7 square root of 2. Again, if you prefer to do it rationalizing the denominator, and that's also done in the PowerPoint, if you would prefer to do it rationalizing the denominator, you will come out with the same answer. But by understanding all these tricks and all these rules, you can figure out different ways of simplifying it, and sometimes one way is quicker than another way. Again, in number 18, we did it 2 different ways. One way was to start with rationalizing the denominator, where we rationalized the square root of 3 at the bottom here by multiplying it by square root of 3 over 3, and then simplifying it by noticing that we can cancel out the 3's, and we got 7 square root of 2. The other way was to simplify everything first and then cancel out the square root of 3 over 3, and we ended up with 7 square root of 2 also. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.